So we're given that both s and t are integers that are greater than 1, and each is a factor of n. That means n is s times some integer. I'm calling it q1 as a quotient. And then n is also t times some other integer. Questions: which of the following must be a factor of n to the power of st? So let me start with the first one. And I can write this as n to the t to the power of s. And actually, no, I'll write it as n to the power s to t. And the reason for that is I want to bring them to the same exponent. So this is same as n to the s over s to the power of t. So that means it's n s times, and then I'm dividing it by s. So you'll see n over s is an integer because s divides n evenly. So that would be some integer, in fact q1. And so now we have nothing in the denominator, so we end up with this product of integers to the power of t, and that will always be an integer. So 1 must be an integer. So right away, that narrows the answer choices to B and E. In fact, you'll see you don't even need to consider choice 3, which is it a factor of s plus t? But you can do this with an example. We can pick n to be 6, s is 2, t is 3. We satisfy these conditions. In this case, s plus 2 is 5. And then n to the power of st would be 6 to the power of 6, which is not divisible by 5. So that's how you can eliminate 3. But because we were able to establish 1, we already narrowed down the answer choices to B and E. Now finally, the second one, which is the hard one, is n to the power of st over st square. So one way we can do this is to use these expressions. So sq1 to the power of st, and then tq2 to the power of st over st. Actually, I'm going to write it as s square and t square. So this we have s to the st over s square, and then t square. And then we have this q1 and q2 to the powers. We can ignore those because these are integers. This is what we need to show, that this is an integer. So we can subtract the 2, and then that's rest is integer, this piece here. So here, because both s and t are greater than 1, the least value they can have is 2 and 2. So we know st has to be greater than or equal to 4. So this is going to be positive, will be an integer, or will be greater than or equal to 2. Same here. So therefore, these two will be integers. And therefore, choice 2 also is a factor of n to the power of st. So the answer is 1 and 2, which is choice E.